for an application that is bogging down my operating system, if I'm looking for an operating system that is thrashing the disk, that's just causing so much I/O traffic to the disk, this is where I'm going to begin. I'm going to have to understand the processes and what they are, and more about exposing information about them so that I can dig down and try to possibly solve the problem. So I want to begin by first defining processes. Processes are launched by executable code. And generally, when you look at the process column, the first executable that you see in each one of these rows, that is the executable code that launched that process. So when you see this exe here, this cam recorder exe, and we see the star 32 means it's a 32-bit process, I'm actually running on this particular laptop Windows 7 64 Enterprise. This 64-bit operating system is also exposing to me the fact that the applications that are running, some of them are 32-bit, not 64. But this camrecorder.exe is the executable code that is going to launch this particular process. So this process is given a process ID. We'll see that in just a minute. When processes run, they require memory space. So every process that runs in an operating system is going to require memory space from the main kernel components of your operating system. They are also given security functions. So they are given boundaries and limitations as to what they can and cannot do within the operating system. This is very critical as we look at processes like IE, the kind of security that is given. Does it make me vulnerable, or does it make me much more secure? Generally, a process represents many files. So when you look over here at camcorder.exe, don't be fooled into thinking that that is the only file that's running in the process. No, that is the file that launched the process. There may be 40, 50, 60 executables, DLLs, and other types of system files that are launched by the process. What we see in the process column, though, is the executable code that launched the process. So generally, when we look at a process, there are many files that are in that process. So don't get confused that when I see camstudio.exe, that is the only file in that process, because that's generally not true. Processes make up the foundation of most operating systems architecture. So it's very important that we understand processes. They are the foundation for almost all operating system architecture. Now I want your attention down here. Notice that we've got, in this particular laptop, we've got running 75 processes. That is the entire amount of processes running by this particular operating system. I can, if I want to look at, and you'll notice as I scroll down, I really see, in this particular case, a limited view of all the processes. What I'm generally seeing is the processes that have been executed under my logon. So when I first open Task Manager, I do not see all the processes. What I am seeing are all the processes that have been launched under my user credentials. If I want to see them all, I come down to Show Processes from All Users. I click on that, and now I begin to see all, including the operating system processes, all the processes in the entire operating system. And right now there's about 75 to 77 processes that make up the entire Windows 7 operating system, including applications that I have launched after logging on. Understanding processes is huge. This is how we discover malware. This is how we dig down and tackle problems like slow applications. This is how we find out what is causing my hard drive to just go crazy. How can I tell whether I am infected with a virus or with a bot? Is there some kind of malware code on my system? It is through this type of understanding that helps me determine those kinds of things. So I'm going to close this out. First thing I want to do is I want to jump in here and spread this thing out, because this thing is awesome. We're going to go up to the view, and I'm going to go to select columns, and I'm going to add something that's very important if I'm looking at processes and I look at some processes that are really taking up CPU time. I notice that their CPU usage is high, and I suspect they look just a little bit strange, and I suspect them as possibly malware. One of the things I can do is add the image path name. In other words, where is this process located? So I'm going to say OK, and I'm going to begin to spread this stuff out. Description, get the description over. I'm going to get the image path name so I can see where is this file that's launching this process. Where is it located on the hard drive? Is it located in the Windows temp directory? That's not a good place for applications to be running from. Is it running in the temporary internet file directory? I am not going to be happy about a process that's running in Windows temporary internet files folder. I am going to be very, very aware of where are these executables actually stored on the hard drive and where are they running from. That may give me some insight. Is this a really suspicious process? I'm already seeing its CPU usage. I'm already concerned about the name of the process. So that would lead me further to be more suspicious and do some homework on that particular process. I can see the memory that it uses. I can take a look at memory usage. I can see under whose credentials that process is running under. So I can see that there are processes running under security credentials of the system. I can see that there's some processes running under the security credentials of myself. I logged on. So you can see there's a variety of different user accounts in which these processes are running under. So that is helpful sometimes as to narrow down who might be the problem. I went ahead to the columns under view, and I went ahead and added the column called process identifier. This gives me the process ID, and I went ahead and added that column. This allows me to see the number assigned by the operating system to every process. Sometimes that's very helpful in tracking down what is the process doing. How is the process interacting with networking? How is it interacting with the performance and use of resources? So sometimes knowing the process ID as I'm hunting down malware or hunting down a misbehaving application, having that process ID identified is very helpful. Let me go to the application tab. Here I have a number of applications running. I'm running obviously in Camtasia, and I would like to know, I'm suspicious about a particular application this particular user is running. I can right mouse click and come right down here and say go to the process that this application is running, and I can check that box, and it pops me right back into the process tab and highlights the process that that application is running in. So again, if I am looking at the application as a suspicious product or malware code or application that is really causing me grief on this laptop, workstation, etc., I may not know what process it is. So I will click on it and right mouse click and say take me to the process. It will take me right to the process tab and highlight the process in which is running that application. So again, I can drill down, look at CPU usage, memory size. I can look at the description. Where is the executable, the image or the executable code that launches the process? Does it look right? Does it look like it's in the right location on the hard drive? Does it smell funny? Does it lend itself to being more suspicious? So those are really cool things that you can do. Now I'm scrolling down as I pull down the processes down to the svc host.exes. Many people are not familiar. They see them, but they're really not sure as to what they are. svc host.exes are simply services. So these processes have been launched by a service in the operating system. So a lot of times I'm looking at a suspicious SVC host process, and I really would like to know what service launched this process. So I can right mouse click again, and it will take me right to the service. And notice it popped me right over into the service tab, and it highlighted all the services that are associated with that svc host.exe. So I really get a chance now to open this up a little bit. Again, notice the process ID is all the same for every one of these services. The svc host, now I can actually drill in, see which ones are running, which ones are stopped. Notice all of these are running. They all have the same process ID because they're a part of that svc host process that we just saw a minute ago. And now I can really see what is inside that svc host. I can see Windows Update, Windows Management Instrument, WMI, themes, and on and on and on. So if I was having a problem with, say, a corrupted DLL that was in charge of themes, and it was really bogging down that process, there's a possibility I could come in here and actually stop that service. So I could do that. So now I could jump down to the service tabs, where it launches right from this dialog box, which is just so awesome. Brings it right up into my little grubby hands, and now I can stop the service, start the service, restart the service, and maybe clear up the process that's causing trouble. This is really awesome. So svc hosts are indicated in the process column with just this single name, which is really confusing. It's like, how can they all be the same name? But they really aren't. They're actually given a different process ID. And to really find out what service they are, right mouse click, go to the services, and you can see it automatically highlights those services that represent that process. And we can see that's 804. This is so cool. And so if you feel like that svc host process is really killing you, you can come over here and maybe restart these services and clear up the problem. You're a hero for the day. This is a great graphic I stole from Wikipedia, and this just is a great picture of processes. When a process is run, it's created. These are the different states that processes can be in anytime they're running in the operating system. Processes are created. They then go into main memory. They can be waiting, just really not doing a whole lot. If there is a need for more main memory, they can be swapped out into virtual memory back to the hard drive. They can be actively running. They can be in a blocked state. They can be swapped in and out again in that particular state. So these are the various things, including after running, they can be terminated. There are great tools by system internals that allow you to actually see this type of activity in processes. Now, I just launched Process Explorer from System Internals, which is a Microsoft tool. And just to kind of give you an idea, you can see the little green highlighted area. Occasionally you'll see a red one. These are processes that are being created. When you see the green, that particular process is being created. There you see one. And then when you see it go red, it's being terminated. And there's this incredible activity among processes that can be turned on, turned off, waiting, blocked, paged to virtual memory or to your hard drive, your page file, and back and forth. So processes make this incredible activity that you understand. Another thing that I want you to understand about processes is that they're hierarchical. In other words, there can be a parent process. Here we see the winit.exe. And notice that there is a child process underneath it. We don't see that hierarchical relationship in Task Manager. We still see the process ID, but we really don't get that sense of the relationship between one process and another. I'm doing this so that you can understand a function in Task Manager. Notice that if I was to terminate this, if I was to right mouse click and kill this process, because all of these other processes are in child relationship to this main process here, it would cause all the child processes to be terminated as well, or at least cause some real mass confusion. As I kill the parent, the kids are going, what? So now Task Manager doesn't show you that. Let's go back and take a look. I'm going to pop up Task Manager. I can go to a process, and notice I can end the process or end the process tree. Now it really doesn't give us that tree relationship that we saw with Process Explorer, but there is a hierarchical relationship. There's a parent process, but what end process tree does is it will end everything. It will end the parent, all the child processes below it, and do it all in one fell swoop. If I was just to end the parent and did not close out the child, it could be real interesting. So you do have that ability to kill a process or end a process and end the process tree. Generally, it's a cleaner way. If you're going to end a process, go ahead and end the process tree. Get rid of all the child processes that are a part of that parent if it is indeed a relationship. Let's go back to Process Explorer real quick. As we scroll down, oh, by the way, the pink ones are services. The blue ones are processes that are run under my credentials. So one thing nice about Process Explorer versus Windows Task Manager is it gives you a few extra visuals that help it, but you still can work within Windows Task Manager fine. Notice that some of this, like this video executable here, this process 3740, there really is nothing underneath it. It is a pure process that if I go ahead and kill it, it is not going to damage any child processes below it. Now on the other hand, Explorer.exe is the parent process to everything that I have run. So if I knock that out, if I go ahead and kill that, which would not be a good idea right now, it would actually blow away or severely affect all the other child processes in relationship. All of this I'm showing you to be careful about ending processes. If you want to do this more carefully, I encourage you to go to Process Explorer. I may do some training on this one. This is an awesome tool in the hands of a tech. I want to show you another cool feature that helps you troubleshoot certain applications that just seem to be they seem to demand a lot of CPU time. They really just seem to bog down. Let me give you a tip to look at as you're working on that particular application. Let's say you launched an application and it was just so slow, and it really caused a performance impact on the machine, and yet the teacher or staff member just had to have it. One of the things you can look at is, one, highlight it and go to processes, and let's find out what process it is in. The second thing, go up to view and let's go into columns, and I want you to scroll down here and check the threads. We'll add threads as one of the items that we'll look at. I'm going to come over here. It popped in right here. So now I can see that this particular application, the stickynotes.exe, has 8-threaded. It's an 8-threaded application, or process, excuse me. This is good because anytime you have multiple threads, you really take full advantage of multiple cores, hyper-threading. So as our processors go to dual core, quad core, I can't wait for my first 8-core, and we add more and more multi-threading capability in our hardware, if our applications are not multi-threaded, they will not benefit at all with a dual core, quad core, 8-core. So I'm scrolling down looking for it. Now here's a great example. Here's a process that has a single thread. This is a lousy application because it really cannot take advantage of a dual core processor. It is a single thread. It will ignore the fact that there are 2 CPUs or that both CPUs handle multi-thread. It's going to just bog down one CPU and leave the other CPU totally idle. We see that here in the Performance tab. Notice I get to see both CPUs, and I really can see in real time that they're not working at the same pace. This CPU over here is really basking in the sun, sitting on the beach, drinking iced tea. And this guy over here is really working hard. So there isn't that equal division of work here on the CPU, and that is primarily because of processes that are single-threaded. So if you see applications, especially older applications, that are not well designed, they're single-threaded, they're not going to be applications that fully take advantage of dual-core, quad-core, 8-way processors. They are just going to really bog down one or the other CPU, and they're going to impact the way the performance of the PC. So just be aware of that. It's good to know when you add applications how many threads they are. Obviously, a application that has only 2 threads is only going to be able to take full advantage of 2 CPUs. The more threads, the better. You really can fully take advantage of more processors, hyper-threading capability in your hardware and your CPU.